Hey guys, I'm back. I have been working on a project at home and I wanted to share a little bit of information with you, and hopefully I can show you all this project in the near future. Now, what I've been working on is electroplating. Electroplating is a process of taking a metal and coating it with another metal. Now, to understand that, you have to understand reduction reactions, oxidation reduction reactions, but you must also have to understand how batteries work. Don't get me wrong, batteries aren't too complicated, but we make them out to be. If you've ever done electrochemistry in one of your classes, you know it sucks. It really does. But we'll try to break it down, kind of give you a simplified version of this, and we can handle more math stuff in the future, but this is really just kind of giving you an overview. Okay, so how does a battery work? Let's start with that. So a battery ends up having, I actually have a picture here. Okay, so this is just from a Google search I did on a galvanic cell, also called a voltaic cell. Basically, you have a metal on one side of your battery that wants to give up electrons. When it gives up electrons, it goes from its metallic state to an ionic state. Notice it has a +2 charge because electrons have a negative charge. So when it loses electrons, it becomes more positive, it breaks off in the solution. These electrons will then go to the other side, so it's going from the anode to the cathode. And when they get to the cathode, it will take in ions from solution, like in this case we have copper. This copper will gain these 2 electrons and then form copper metal and starts plating onto this electrode. So this electrode will start degrading and this one will start building up. As that happens, we have, since we're losing positive charges here because we're sticking onto the electrode, positive charges would like to move over, but depending on the porous disk, that might not be possible. But because you're gaining positive charges on this side, something that definitely will happen is that negative charges will flow over to balance that, because you have to have roughly the same charges on both sides. In this case, you can see they're using sulfate as their ion in both cases, SO4, and that makes this a little bit easier. You can use salt bridges. It doesn't necessarily have to be a porous disk. There's all kinds of ways of going about this. Okay, so I think this is really cool. This is really just like the basics of a battery. But what happens if you want the flow to go in reverse? And that's where electroplating comes in. If you want the flow to go in reverse, you have to input a battery into the middle of the design. So let's look at a quick picture. This is just kind of a rough sketch, just to kind of get a point across. Okay, so basically, let's just say this was our anode, this was our cathode. So electrons are flowing out. And as they flow, they induce some kind of voltage. I'm going to leave this space empty because I want to put something there. As they flow, it induces, let's just make up a number, let's say it's inducing 2 volts. If I put a battery here in the middle, with its negative side here and its positive side here, maybe it's a 6-volt battery, it will cause a net in this direction of 4 volts. And a good way of looking at voltage is to consider it as pressure. Basically, that you can think of as like electrical pressure. It's also called potential. What we can think of is like we're pushing with 2 volts and we're pushing with 6 volts. The 6 volts is going to win, and we have a net of 4 volts going in this direction. What this means is that even if this metal doesn't want to be plated, it's going to be plated because the battery is going to force it to be plated. Now, you don't have to actually have a voltage coming off of your initial source, like this says 2 volts, but it is possible that you have something like copper and copper. Like, why? But you can. I mean, you do when you do electroplating, but you could do this, in which case the net, you have 0 to start with, so the net would be 6 in one direction. But let's say we took a metal like stainless steel, so we have iron here. And actually, let's check this real quick. Which one would prefer to be oxidized, iron or copper? To figure that out, we can look at reduction potentials. If you run a Google search on reduction potentials, you get this nice little chart. So let's take a look. Copper has a reduction potential of 0.34. So from it going from 2+ to its metallic form, pretty likely, 0.34. Let's take a look at iron. Iron has a negative value. Negative means it doesn't want to be reduced, but it wants to be oxidized, which is perfect, because if we want it to give up electrons, we need to reverse this reaction. We go from iron to iron ions, because that would release the 2 electrons. So that's good. So this would actually be what we say a spontaneous reaction. So we have iron here, we have copper here. It will induce a voltage and it will try to flow in this direction. But what if we want to coat this iron? What you can do is you can submerge these electrons in some kind of bath of, let's say, sulfuric acid. Oops, my pen's acting up. Sulfuric acid, H2SO4, and maybe some copper. Well, definitely some copper sulfate. Since we have copper sulfate in this solution, as this voltage is moving around, basically now on this side, instead of having copper come in and build this electrode bigger, copper ions are going to be breaking off. So we're going to be gaining the copper 2+ in solution, while 2 electrons travels outwards. Now these electrons will come to this side, and then copper will start depositing onto this electrode. So it'll go from being an iron electrode to a copper one. There's iron at the core, but copper on the outsides. Once that is done, then you can think of it as 2 copper electrodes, more or less, because that's what's in solution, which is why I said electroplating is, you could think of it as like 2 copper electrodes. Not from the get-go, it'd be iron and copper, but eventually it becomes copper and copper. Now I am in the process of doing something with this because I think it's kind of cool. I mean, right now I'm doing copper just to get some experience and some practice. Later I'll be doing gold because gold is expensive as hell. So if I could take some cheap stainless steel or some metal like that, coat it in gold, I can make lots of fancy things that only cost me a few dollars to make, which I would greatly appreciate. Other things that come out of this, well, I guess a good example is that you can learn how to make batteries out of dirt, fertilizer, any kind of salt, pretty much if you can get a hold of 2 metals, some wiring, and you can get a hold of some kind of electrolyte like salt or acids or whatever, you can make a battery. It might not be a very strong one, it might have a very low voltage, but you can add them together in series, all their voltages will add together, and you can make a fairly decent battery off of that. There's plenty of YouTube channels of people trying to do it. I will try messing around myself. I have a multimeter, although it's a pretty cheap one, so I don't know how effective it will be. But I'm going to start doing some experimenting, and I'll let y'all know how it goes. But yeah, there you go. This is basically how batteries work and how electrolytic cells work. And once I start videotaping that, I will gladly update y'all so y'all can see the process. Alright guys, peace out.